Thanks, David, and welcome everyone. Thank you for choosing to attend this session. My name is Chris Markson, and I'm a data science senior manager at Evernorth Research Institute. Today, I'm going to be talking about using generative AI for data extraction clinical support. So for those of you who don't know, Evernorth, I just want to give a quick background on the organization. So we're a subsidiary of Cigna Corporation, and we focus on pharmacy, care, and benefit solutions. I'm part of the Evernorth Research Institute, which really has two different arms, one that focuses on clinical outcomes research, and the other focuses on data science solutions within the organization. As part of the data science organization, we have quite a few different core competencies that range from traditional AI and predictive modeling to NLP and text mining. But they're all really rooted in affordability, simplicity, and predictability. We've worked with John Snow Labs over the years, specifically using some of their technologies on understanding member experience in a clinical setting. But more specifically, today I'm going to talk about prior authorization and some of the opportunities that we have in that area to help streamline the process. So before I talk about prior authorization, I have to talk a little bit about utilization management and what it is. Ultimately, how this is set up, and why is it needed? This is set up for our clients to help understand and define what their coverage criteria is for a particular benefit. And it has quite a few different benefits associated with it. One is it allows for more affordable premiums so that we know what we're covering on behalf of a client. It also reduces waste in the case that folks who need therapy are the ones who are getting it. But most importantly, it has clinical checks in place to make sure that the medications that are being administered or distributed are safe and effective for individuals. But alongside that, we know that there are certainly challenges associated with the process. It's a burden on the prescriber where they have to send information to show that their patient meets coverage criteria. They also create challenges on the patient experience side, where patients might not know the process or how to navigate it. And from the operations side, it has processing times associated with it as clinical reviewers look at documentation, and that documentation can be lengthy at times. We've seen documents that are provided upwards of 500 pages long for a clinical record. So it obviously takes time and effort for clinical reviewers to sift through that documentation and find the information that's needed. So for this project, we were tasked with coming up with a solution that would get medications to patients who need them sooner, as well as reducing the time, effort, and expense for processing those prior authorizations. And all along that, we also have to make sure that we're meeting our clients' criteria for coverage. So let me take you through the project that we started this on. This is a GLP-1 project, and for those of you who aren't familiar with GLP-1s, they're a popular weight loss and diabetes medication solution. We were tasked with dealing with the incoming flux of prior authorization cases under the GLP-1 umbrella. And we really needed to demonstrate that generative AI was a viable solution for helping to speed up the prior authorization process. Specifically, we were tasked with, as a data science team, extracting out clinical information for A1C, BMI, and diagnosis codes from clinical documents submitted by physician offices. Ultimately, when we first started this project, we decided that there were really three objectives. One was, what's the viability of generative AI in this use case? Two, what's an appropriate use of a user interface that could easily show this information to a clinical reviewer? And three, what's the path to scalability and further automation down the road? Ultimately, the objectives associated with this is a reduction in time for processing each of these cases, along with increased clinical capacity for the existing clinical reviewer staff to process cases more effectively and efficiently, and improving or remaining static with the clinical decision accuracy. So getting to the right information in the fastest amount of time possible while remaining accurate. This certainly wasn't a one team operation. This really focused on quite a few different teams across the organization. And I feel like with any organization that's attempting to implement some type of generative AI solution, this will likely be the case. Uh, we had quite a few different stakeholders who were involved in the build out of this solution that obviously included us on the Research Institute and the data science team. We partnered with technology for advice on architecture and solution implementation. We worked with our AI Center of Enablement, who provides guidelines in how AI and generative AI can be used within the organization, along with operations and clinical teams to help understand the existing process as well as any of the clinical implications in extracting out this data. And finally, the platform team for understanding how can we get this deployed in a scalable and robust solution. We started this process back in May of 2024, and we quickly jumped into testing out what's a viable solution for this problem that we identified. We then identified a potential UI solution, as well as my team focused on the generative AI portion of it. We ultimately landed on releasing this in production the end of November, which again was a tight timeline in getting all of these teams synced and the architecture deployed in a production-ready setting. Since then, we released it in November. Since then, we've been monitoring the performance of it and tracking for how we could make improvements going forward. So I think these guiding principles sort of highlight how we focused on this problem, and I think are applicable to many different organizations. Our AI COE has a policy of human in the loop for any generative AI solution. And that makes sure that we have eyes on the output from the generative AI generation. We're making sure that the clinical extraction of these elements is appropriate and sound. We're not hallucinating in our results coming out of the Gen AI solution. We also had a guidance in minimizing disruption with the clinical reviewers. Again, they're tasked with processing these cases as quickly as possible to get the medication in the hands of the folks who need it. And so we wanted to support the process and minimize the disruption to make sure that we're speeding it up, not creating an additional barrier. We made very small and strategic steps in how we were implementing and what decisions we were making in the process to make sure that we were, again, supporting the clinical reviewers at the end. Testing, learning, and validate was very important for us to understand what are we doing right and where do we have opportunities for improvement. And one critical element of this was getting direct feedback from the clinical reviewers that was constant and up to date. We had a constant feedback loop concept from the very beginning of this project that got implemented and results back in our hands so that we could easily pivot and improve the results coming out of the Gen AI solution. And I think that was something that was critical to our success now, looking at what our roadmap is ahead, knowing what works and knowing what didn't work directly from the clinical reviewers. So let me jump into some of the experiments that we ran in the beginning. And before I do that, I just want to talk a little bit about what's happening on the back end at a high level. So for the prior authorization process, when a prescriber requests a medication that has a prior auth associated with it, it generates a PA case on our side that requests specific documentation from the prescriber. They then fax that in or scan it, submit it online to our system where we receive that fax. In the past, what happens is the clinical reviewers would receive the documentation, review it, extract out the elements that are required for the clinical criteria, and then pass that along to a system that would decide the state of the prior authorization based on the clinical criteria extracted. Where we came into this is looking at it as an LLM support tool that would look at these faxes, again, that come in all shapes and sizes, process the information that we needed for the prior authorization, and present it to the clinical reviewer in an easy to review fashion, where they could look at the document, look at the extracted elements, certify the results, and pass it into the PA decision system. When we looked at this process, we saw that there were two obvious initial steps. One was use a multimodal LLM, pass it the facts directly, and ask it questions to extract out the relevant elements, again, being A1C, BMI, and diagnosis codes. On the other hand, we thought, well, we could probably just OCR it first, get the text out from the optical character recognition, clean it up, and then pass it over to the LLM. Ultimately, what we found was that using OCR coupled with LLM gave us much better control over the information going into the LLM and the ability to attach additional metadata or do any cleanup before we prompted the LLM. This was a big win for us and definitely increased our accuracy. So let me go into some of the key features of this tool and what it's able to do. So you can see on the right-hand side here, this is just an example of a text or of a fax coming in. Again, representative of how the quality can vary from one fax to another. They could come in crystal clear or come in very messy like this one. Our task was to extract A1C, BMI, and diagnosis codes, but alongside that, we also had to pair those with measure dates or diagnosis dates, page number, and section. And the reason we needed page number and section was the UI was built to allow the clinical reviewer to click on a specific entity and be taken directly to that page for manual review. This reduced the time that they had to scroll through the document, find the specific page where we extracted it, and then go on to their next task. In addition to that, we were able to incorporate several quality checks within the system, which allowed things like ICD-10 cross-checking between the diagnosis code and the diagnosis name, since the LLM has inherent understanding of what an ICD-10 code is. Range verification, so if there were values that we extracted out that were way outside of the typical range of a particular measure, we were able to flag that and double check it. Also, just checking things like units in the case where metric and imperial might be used interchangeably in a particular document, and making sure that we had consistency in how we were reporting that back. In addition to this, we also incorporated some tools like auto processing for BMI. In the scenario where we have BMI values not explicitly stated within a clinical document, we were able to automatically calculate that BMI from height and weight values that were extracted out from the clinical document and provide that directly to the clinical reviewer. All in all, we've processed about 120 cases or 120,000 cases since we've been in production for about 3 months, with a less than 1% error rate reported by clinical reviewers and really robust uptime. This system has rarely gone down or had any issues, and results are ready and presented to clinical reviewers in a matter of moments. So from a UI standpoint, this is just again, a representation of some of the documents coming in where they are, regardless of the format of the fax or PDF that came in, presented in a consistent view that's tabular and shows each of the values, A1C, BMI, and diagnosis code, along with their measure dates. Users can go in and click on specific elements, and they'll be taken directly to that page where it was found. And within the UI, and most importantly, they're able to check off specific elements, provide feedback that then comes directly to our team the next day so that we can review, reproduce, and make adjustments to any future development. All in all, we've had a lot of success with this project, but there's obviously opportunity for where we can go in the future. And so the roadmap ahead, again, these are really derived from things that we heard directly from feedback from clinicians coming through our daily reports. A mix of both things that are working and things that might not be working. First is the token cost perspective. So right now we're paying for these documents to be sent over to the LLM after they've been processed by the OCR technology. Our opportunity here is to reduce the amount of tokens that we're sending to the LLM as much as possible while still maintaining clinical context. And so one of the big opportunities with this is using John Snow Labs named entity recognition modules to help us identify this information beforehand coming out of the text data, and then send it over only when it's relevant to the LLM. In addition to this, we could use NER to pre-process some of the data, automatically tag elements, and provide additional metadata within the document to help better understand what we're sending over to the LLM. And this will ease the expansion into other therapies beyond GLP-1s. Lastly, from a focus standpoint, what we found is putting in too much clinical data within the document creates confusion within the LLM and reduces the chances of it extracting out all of the records. And so by focusing it using NER or pre-processing techniques, we can easily remove unnecessary information from the prompt, but also reduces the chances of the LLM forgetting earlier context within the document. And in addition to that, we could reduce context window challenges that we might run into on some of the models that have limited space as far as input context goes. So this is where we are and where we're headed. Thank you for taking some time to listen to this talk. We've had a lot of success with this project, and we're excited about where it's going to go in the future. And I hope you enjoy the rest of the NLP Summit today. Thank you.